This video lesson is all about system of linear equations. System of linear equations is a collection of two or more equations involving the same set of variables. This video lesson has three parts. Let us start with part 1, wherein we will find out if the given coordinates is a part of the solution or not. When we say solution, it is the answer to the given system of linear equation. Example number 1, y equals x plus 2 and 2x minus 3y equals negative 7. So we need to find out if 0 and 2 is part of the solution or 1 and 3. First, you will just need to substitute the values of x and y. So in the first equation, x is 0 and y is 2. So we will substitute in the first one. So we have y equals x plus 2, y is 2 equals x is 0, copy plus 2, and then simplify. 2 equals 0 plus 2 is 2, so this is correct. Next, we also need to substitute in the second equation. So we have 2x minus 3y equals negative 7. So we will have 2. So we have 2 times the value of x, 0, minus 3, the value of y is 2, equals negative 7. Then we will multiply 2 times 0, that is 0, so we don't need to write it. Negative 3 times 2, that is negative 6, equals negative 7. So this statement is not true because negative 6 is not equal to negative 7, meaning 0 and 2 is not part of the solution. How about 1 and 3? So we will find out if 1 and 3 is part of the solution of this system. So we have x is 1 and y is 3. Substitute it in the first equation. Y is 3 equals x is 1 plus 2. 3 equals 1 plus 2, that is 3. So this is correct. For the second equation, we have 2 times x, which is 1, minus 3 times y, which is 3, equals negative 7. Then multiply 2 times 1, that is 2, negative 3 times 3, that is negative 9, equals negative 7. So we have 2 minus 9, different sign minus, so we have negative 7 equals negative 7. This statement is also true, meaning 1 and 3 is part of the solution of this given. Example number 2, 4x minus y equals negative 1 and x plus 7y equals 7. We have 1, negative 3, 0, and 1. So we need to find out which is part of the solution between these two coordinates. So we will have the first coordinate, x is 1, y is negative 3. So we will substitute with the first equation. 4 times the value of x, which is 1, minus the value of y, which is negative 3, equals negative 1. Multiply 4 times 1, that is 4. Negative times negative 3, that is positive 3, equals negative 1. 4 plus 3, that is 7, equals negative 1. This statement is not true since 7 is not equal to negative 1. How about in the second equation? So we have x plus 7y equals 7. So x is 1 plus 7 times negative 3 equals 7. So we have 7 times negative 3, that is negative 21, equals 7. So we have 1 minus 21, that is negative 20, equals 7. Still, this is not true. So we need to have two true answers to make it part of the solution. Let us have the second coordinate, 0 and 1. X is 0, y is 1. First equation, we have 4 times 0 minus 1 equals negative 1. 4 times 0, that is 0, so we don't need to write it. So we have negative 1 equals negative 1. This statement is true. Next, x is 0 plus 7 times y, which is 1, equals 7. So we don't need to write 0, so we have 7 times 1, that is 7, equals 7. Also, this is true. In this example, the first coordinate is not part of the solution, while the second coordinate is part of the solution. Part 2. So in this part, we will find out if the system is consistent or inconsistent, if it is dependent or independent. Example number 1. X plus y equals 5. X minus y equals 1. So there is a shortcut in finding if the characteristics of the system. So we will use a sub 1 over a sub 2 equals b sub 1 over b sub 2 equals c sub 1 over c sub 2. A sub 1, a sub 2, we will get the numerical coefficient of x. So in the first equation, the numerical coefficient of x is 1. And then for the second equation, the numerical coefficient is also 1. For the b, we need to get the numerical coefficient of y. So we have b sub 1 is 1 over b sub 2 is negative 1. And then for the constant, equation 1 has 5 and equation 2 has 1. And then we will simplify 1 divided by 1, that is 1. 1 divided by negative 1, that is negative 1. And then 5 divided by 1, that is 5. So here, 1 is not equal to negative 1 and negative 1 is not equal to 5. If this is the case, if all your answers are not equal, meaning this system is consistent and independent and the graph is intersecting lines, it has one unique solution and the equations are not equivalent. Example number 2. 3x plus 2y equals 6. 6x plus 4y equals 12. Same, we will use the shortcut a sub 1 over a sub 2 equals b sub 1 over b sub 2 equals c sub 1 over c sub. A sub 1 is 3, a sub 2 is 6 equals b sub 1 is 2, b sub 2 is 4, c sub 1 is 6, and c sub 2 is 12. And then we will simplify or make it in the lowest term. 3 over 6 is divisible by 3, so we will have 1/2. 2 over 4 is divisible by 2, so we will have 1/2 also. And then 6 over 12 is divisible by 6, so we will have 1/2. Here, all your answers are equal. If that is the case, the system is consistent and dependent. The graph is coincident lines, meaning one line is above the other line or the two lines are just the same. It has infinite solutions and they are equivalent equations. Example number 3. 2x minus y equals 5 and 2x minus y equals 3. We will use the shortcut. Our a sub 1 here is 2, a sub 2 is 2 equals b sub 1 is negative 1 over b sub 2 is negative 1. C sub 1 is 5 over C sub 2 is 3. So we have 2 divided by 2, that is 1, equals negative 1 divided by negative 1, that is also 1, equals 5 over 3. So here, 1 is equals to 1, but 1 is not equal to 5 over 3. If that is the case, meaning the system is inconsistent and independent, the graph is parallel lines, there is no solution, and the equations are not equivalent. Now let us have the last part. So here, we need to solve the values of x and y or the solution of the system. Example number 1. 2x plus y equals 3 and negative 2x plus y equals 5. In here, we will add the first equation and the second equation. So we will have 2x plus negative 2x. Since they have different sign, we will minus. So 2 minus 2, that is 0. So we have 0x. So we don't need to write it. Next, we have y plus y. They are understood to have 1 as the numerical coefficient. So we have 1 plus 1, that is 2. And then copy y equals 3 plus 5, that is 8. And then to get the value of y, we need to divide both sides by 2. So 2 divided by 2, that is cancelled, or it will become 1. And then copy y. 8 divided by 2 is 4. So the value of y is 4. Next, we will substitute to get the value of x. So you can choose which equation you want to use. So in this case, I want to use the first equation, 2x plus y equals 3, where y is 4. So we will substitute the value of y. So we have 2x plus y is 4 equals 3. We will use the left and the right side. So the term with variable will remain in the left side while the constant will be transposed in the right side. So copy 2x. 4 should be transposed from the left to the right side. So from positive, it will become negative 4. And then 3 is positive, copy. So we have 2x equals negative 4 plus 3, that is negative 1, unlike sign. So we will divide both sides by 2 to get the value of x. 2 will be cancelled, it will become 1. So here, x is equals to negative 1/2. If you will write the coordinates, x always comes first. So we have negative 1/2 and then y is 4. So this is the solution of the system. Example number 2. X plus y equals 4 and x minus 2y equals 16. So in this example, we cannot cancel right away any of the variables. So what will we do is to have same numerical coefficient but different sign. So in this example, we will deal with the variable y. We need to multiply the first equation by 2. So we will have 2 times x, that is 2x. 2 times y, that is 2y, equals 4 times 2, that is 8. And then copy equation number 2. So now we can cancel 2y minus 2y because it will become 0. And then we have 2x plus x, that is 3x, equals 8 plus 16, that is 24. Divide both sides by 3 to get the value of x. So 3 divided by 3, that will become 1. So we will copy x equals 24 divided by 3, that is 8. Last example, 3x plus 14y equals 203. 11x plus 11y equals 220. So as you can observe, we don't have a like sign and we don't have the same numerical coefficient. So what will we do is to multiply numbers so that we can have the same term that can be cancelled. So the first equation should be multiplied by 11. So we have 11 times 3x, that is 33x. 11 times 14y, that is 100, that is 154y. 203 times 11, that is 2233. Next, we will multiply the second equation by negative 3. So we will have negative 3 times 11x, that is negative 33x. Negative 3 times 11y, that is negative 33y, equals 220 times negative 3, that is negative 660. And now, 33x minus 33x, it will become 0x, so we don't need to write it. 154y minus 33y, that is 121y, equals 2233 minus 660. So that is 1,573. And then divide both sides by 121 to get y. So 121 divided by 121 will become 1. Cancelled. So y equals 1,573 divided by 120 is equals to 13. So that is the value of y. What is the value of x? So we will return to the original equations. So we will use the first equation, 3x plus 14y equals 203. And then substitute the value of y. So we have 3x plus 14 times 13 equals 203. Copy 3x. 14 times 13, that is 182. Copy 203. And then we will use the left and the right side. So 3x is at the correct place. So we will just copy equals 182 should be at the right side. So change the sign. It will become negative 182 plus 203. And then copy 3x equals negative 182 plus 203. Different sign, minus. So we will have 21. To get the value of x, we need to divide both sides by 3. So 3 divided by 3, that will become 1. So cancel. So we have x equals 21 divided by 3, that is 7. So the value of x is 7. So the solution of this system is 7 and 13.